specifically. Specifically today, we are finishing up our, hold on, hold on. My goodness. Okay. Today we are finishing up our 2D geometry. And what we've been working on so far in the series is we've looked at all of the rules that relate to triangles. Now, the reason why we've spent so much time on triangles is because there are a lot of rules that relate to triangles. And rules with triangles are so commonly asked. Now, obviously, triangles are not our only 2D shape. The other 2D shape that we are very concerned about is quadrilaterals. So that brings us to this first question over here. What are quadrilaterals? And so you guys can let me know in the chat if you have an answer, but I do see a hand raised. I don't know. It is a Bree, yes.
Hi, ma'am.
Hi.
A calculator is a flat shape or a polygon which is 2D that equals to 360 degrees.
Okay. You are quite like unclear, but I heard a polygon.
Um, Polygon is
There we
a
go.
polygon with four sides and equals
Uh-huh.
to 360 degrees.
What equals to 360
Are
degrees?
the quadrilaterals.
You
All
see, you're not being specific enough. Is it the length
others
of the sides that equal 360?
are the sum of angles.
100%. Thank you. The sum of angles equal to 360 degrees in any quadrilateral. And so, Brie, I did think I heard you telling me what a polygon is. What does a polygon mean?
It's a flat shape or like
It's a flat shape. So
3D.
it's a 2D shape. And there's one other characteristic that I'm worried about with a polygon. Do you know what that is?
Um, Straight sides. Or like
There you go. It's a 2D shape with only straight sides. Thank you very much, Bree.
K-man.
So we have a polygon, and a polygon is a 2D shape with straight sides, and a quadrilateral is a polygon with four sides. So it's a four-sided polygon, a shape that is 2D that has four straight sides. And I see you guys answering in the chat, so that is good. You guys all have the correct answer. And so now quadrilaterals are a very big group. So it's almost like if you think of fast food restaurants, it's like almost like a big heading. And there are many different fast food places that can fall into that category. So under quadrilaterals, we have many different types of quadrilaterals, which I'm sure you guys are familiar with some of them. Now, let's start by looking at characteristics of some of these quadrilaterals. Now, you'll see there's already writing in here. Our grade 8 teacher from last year did these notes with her kids, and I just thought I'd save time by keeping her writing in. Um, and so we start with a trapezoid, or what we more commonly know as a trapezium. Okay. And now, when I talk about a characteristic, okay, I mean something that is present in every single one of those shapes. Something that, if the shape is missing that, it can't be that specific shape. So, when I talk about characteristics, you must know that every single trapezium is going to have this characteristic. And the characteristic of a trapezium is that one pair of opposite sides are parallel. So, here I see this side is opposite to the side at the bottom. And so usually it is the top and bottom sides that are the opposite sides that are parallel. But also you'll be able to see from the diagram which sides are parallel. So you can clearly see these lines over here do not look like they are parallel. And that's all that it takes to have a trapezium. If you're given a shape that only has two parallel sides and nothing else that can distinguish it, then you can say this four-sided shape is a trapezium. Okay? A trapezium can be broken down further into a isosceles trapezium. And the characteristics of an isosceles trapezium is that we have one pair of opposite sides that are parallel. So we still have these parallel lines at the top and the bottom, but my non-parallel sides are equal. So in other words, this line is equal to this line. And when I say the line is equal, I mean the length of the line. So if this side is 2 centimeters, and they've told me that this is an isosceles trapezium, because of the characteristics of this trapezium, I know that the other side also has to be 2 centimeters, because in an isosceles trapezium, my non-parallel sides are equal to each other. And very similar to what we learned with triangles, the angles opposite my equal sides are equal. So these are the angles that are opposite those equal sides, and these angles are equal angles. I'm going to stop here. I'm going to check in because this is just a little bit of what we're going through today. Are we all happy with trapeziums, both the normal trapezium and the isosceles trapezium? We understand the characteristics. Any questions? Liahu was studying trapeziums. Liahu was studying quadrilaterals today. I hope that this is going to help Liahu. Okay. Let's move on. We then have a kite. And I don't want you guys to be looking at that. So now we're looking at a kite. Now you can see there's quite a lot going on here with my kite. The first thing that I see is that we have two pairs of adjacent sides that are equal. Somebody tell me, what does adjacent mean again? When I say adjacent, what does that mean? Next to. Bree, yes.
I wanted to say the answer, but Uma already said it.
Okay, so Bree, while you're here, do you want to tell me, so if I'm saying that the adjacent sides are equal, do you want to tell me which sides you think are equal?
Um, I don't know how to actually describe them, but like the sides that are
Okay,
next to
let
each
me
other.
label it A, B, C, D. So I've labeled the 4 points. Tell me which lines are equal.
A and C. Angle A and angle C. Wait,
So remember, I'm not talking about angles yet. We're talking about the sides. So when you
I'm
talk about
sorry.
the sides, you're going to say AB or BC or CD or AD.
Oh, AC
Mm-hmm.
or
Well,
CA.
this would be AC. But remember, I'm talking about now the existing sides of the shape. In the existing sides of my kite, two pairs of my adjacent sides are equal. So, Brie, what actually happens is, do you see that this side and this side are adjacent to each other? AB and BC are adjacent to each other.
Yes.
So those sides are my equal sides. And that's my first pair. But they've told me that we have two pairs of adjacent sides, which means that this two sides are also equal to each other. Do you see that?
Yes, I do.
Cool. Thank you, Bree. Itandile, I saw your hand up. Intle, you're close. It's not so much close to or near each other, but it's when we talk about adjacent in maths, we literally mean next to. So if I talk about an adjacent angle, I mean the angle next to it. If I talk about an adjacent side, I mean the side next to it. Cool. Then if we look at our green characteristic over here, they said one pair of opposite angles are equal. Okay. And in brackets, you'll see it says between the non-equal sides. Now, and I actually want to zoom in more. Like that. So what do I mean? Remember, we have equal sides. We have two pairs of equal sides, but there's also an angle that forms in between those non-equal sides. Because remember, this and this is not equal to each other. So when we say between the non-equal sides, we're just trying to distinguish that it's these two angles that are equal to each other and not these. Okay. So I actually want to do that in green. Um, so we have my angles that are equal to each other, and it's specifically the angles that are in between my non-equal sides. Okay. Opposite angles are equal, and it's specifically the angles in between my non-equal sides. Now, this word is something you're going to see a lot when we talk about quadrilaterals, and this is diagonal. Now, when I talk about a diagonal, what a diagonal does is a diagonal is firstly a line, and it's a line that joins two opposite corners. So here I see this corner is opposite to this corner, and when I take a line and I join those corners, that is going to give me what we call a diagonal. Okay. And so what they're saying is that one diagonal is bisected. So if you look at if I draw in my diagonals, I obviously will have two diagonals because my two diagonals will join my four corners. Okay, so I've now drawn in my diagonals, and they have said that one diagonal is bisected. And immediately I can see this part of my diagonal looks like it's equal to this side. Now, keep in mind, you can't just assume because it looks, but because I'm telling you this is a characteristic of a kite. Whenever you see a kite, you can always assume that your shorter diagonal is bisected. So let me actually make a note here. Your shorter diagonal is the one that is bisected. And if you're also confused about this word bisected, when you see the word bisected, all that it means is, and I almost wanna, it means that it's cut exactly in half. Okay? Exactly in half. That is what we mean when we say bisected. So here, one of my diagonals are bisected by the other one. And we can see that, and let me label the shape again, A, B, C, D. We can see that AC has been cut exactly in half by the line BD. Now, I just want to check in. Do we all understand this rule? Because I know, again, it's a lot of info, but as long as you understand it now, beyond this, all you have to do is memorize. Unfortunately, there's no way around it, there's no shortcut. You have to memorize the characteristics, the properties of your quadrilaterals. Okay, if you guys do still have questions, you are more than welcome to ask. And then the other thing that they have said is that my diagonals intersect at 90. Now, if you don't know what intersect means, intersect just means a place where they cross each other. So my diagonals cross each other at a 90-degree angle. And so from that, I can go ahead and say my diagonals are crossing each other. They intersect each other at a 90-degree angle. And then my last characteristic, my last property for a kite is that the unequal opposite angles are bisected by the diagonal. So remember, we have angles that are unequal, and that would be angle D over here and angle B. So those unequal but opposite angles are bisected by the diagonal. And remember, what does bisect mean? It means it's cut exactly in half. So in other words, if they tell you that this full angle over here is 60 degrees, and they ask you what is the value of x, and x is only that one little angle, x is angle BDC, you know, because of the properties of a kite, that my diagonal has bisected that full angle in half. It's or bisected in half is saying the same thing, but we know that it's been cut in half. We know that it's been bisected. So I can go and say angle BDC is going to be 30 degrees. Why? Because of properties of a kite. Diagonal bisects angle. Hi Kia, that is okay. Glad to have you with us. So this is now my properties of a kite. Are we following? Are we understanding? Let me know. Yeah, let me know. And then so what I'm going to do is I'm going to say this is going to be x, and this will also be x, and this will be y, and this will also be y, because they've been cut exactly in half. Remember, bisect means half. If we have half of something, it means my two portions are identical. They look exactly the same, you know. Okay, I'm not seeing questions, so I am going to move on. We are then going to move on to a parallelogram. Now, this is such an important shape. And actually, let me have the rectangle up here while we're dealing with this. Your rectangle is such an important shape. It's super, super important because it's tested almost as much as triangles are tested. So if there's any shape you're going to want to memorize the properties of first, it's going to be your parallelogram. Now, what are the properties of my parallelogram? Well, firstly, both pairs of opposite sides are equal. So opposite side, those are equal, and those are equal. Okay, so if I had to label this A, B, C, D, what would happen is AB is equals to DC, and AD is equal to BC. So if they give you a parallelogram and they tell you this side is 6 centimeters, and then they ask you what's the length of side BC, you have to know the opposite sides in my parallelogram are equal. And so this means that BC will also be 6 centimeters. Okay, so if you were confused about why are we learning about all of these properties of quadrilaterals in general, it's because when we do geometry, sometimes they give us quadrilaterals and we have to find missing lengths and missing angles. And like we've been building our toolbox, the properties of quadrilaterals literally are putting so many more tools into your toolbox, so that when you have to find these missing angles and these missing sides, you have a lot more tools to work with. Obviously, these tools will only work with that specific shape. So the properties of a parallelogram can only be used when they've told you this shape is a parallelogram. Otherwise, you can never assume. If they give you a shape and it looks like a rectangle, you can never assume it's a rectangle. Okay, you always have to prove. So keep in mind that with geometry is that we're always looking for the easiest way, but you cannot just look at a rectangle or a shape that looks like a rectangle and say this is a rectangle if they haven't told you. You can never assume. If you're going to use the properties of a rectangle, you're going to have to prove that it's a rectangle first. Anyways, that was a bit of a side note, but still super important. So we've now done our first property. Both pairs of opposite sides are equal. Looking at the second property of parallelograms, we also have that both pairs of my opposite sides are parallel. And so AD is parallel to BC, and AB is parallel to DC or CD. Okay, so we have that my opposite sides are equal and parallel. Those are my properties of a parallelogram. Looking at the next one, we have that opposite angles are equal. And so that means that angle A is equal to angle C, and angle D will be equal to angle B. And lastly, we have that the diagonals bisect each other. So remember, when we are looking at a diagonal, it is the line that joins my opposite corners. And I'm trying very hard to draw straight lines. I think that's good enough. My diagonals bisect each other, meaning these two little lines are equal, and so are these. Okay, now keep in mind that they did not say that my diagonals are equal. My diagonals are not equal, but when they cross each other, they both cut each other exactly in half. Okay, a lot of info. As I said, those are the properties of a parallelogram. How are we feeling? Are we on track? Do we understand the properties?
Yes, ma'am.
Thank you, Liaho. I saw Uma had a lot of thumbs ups. Bri, I saw yours, and I think I saw Gloria's. Itandile, what's wrong?
To be exact, ma'am, I didn't understand like the properties of a kite and a parallelogram.
Okay. What did you not understand?
Like, ma'am, the diagonal part when they bisect, and when the diagonals intersect at a 90 degree and stuff.
Okay. So what I firstly want to ask is, do you understand what a diagonal is?
Yes, ma'am, I do understand what the diagonal is.
Okay. And do you understand what I mean when I say something is bisected?
Yes, ma'am.
Okay. And you also understand what I mean when I say something intersects?
Yes, ma'am.
Okay, cool. So now that we know all of our terminology, what we said here is that when you draw in your diagonals on a kite, one of your diagonals will be bisected, meaning one of your diagonals will be cut exactly in half. And the diagonal that's going to be cut exactly in half is going to be your shorter diagonal. So if you look at your kite, do you see that there's a long diagonal and then there's also a short diagonal?
Yes, ma'am.
Okay. And what I'm telling you is that part of the properties of a kite is that when you draw in those diagonals, the long diagonal cuts the short diagonal exactly in half. Does that make sense?
Yes, ma'am.
So that is this property that one diagonal is bisected. And let's maybe add something in here. Let's say my long diagonal cuts the short diagonal in half. Does that make more sense?
Yes, ma'am, it does.
Cool. So that's that property over there. One diagonal is bisected. To put it in more understandable terms, my long diagonal cuts the short diagonal exactly in half. And that's why I have these two markings over here to indicate that those two parts of the lines are equal because they've been cut exactly in half. Does that make sense?
Yes, ma'am, it does.
Cool. Then I've now also said that the diagonals intersect at 90 degrees. Now remember, when we say something intersects, it just means the place at which they cross. It means that, okay, let me say when they intersect, it means that they cross each other. Okay, it means that at one point they overlap each other, they cut across each other. And what this rule is saying is that that place at which they intersect, the angle is going to be 90 degrees. So you could put this 90-degree sign anywhere, okay? Because if you think about it, if this is 90 degrees, then because of angles on a straight line, this side over here is also going to be 90 degrees. And then because of angles on a straight line, this side is also going to be 90 degrees. And angles on a straight line, this is also going to be 90 degrees. So do you see that all around, whatever angle I look at where they intersect, all of those angles are 90-degree angles?
Yes, ma'am.
Does that make sense?
Yes, ma'am, it does.
Are you sure you're with me? You don't have any other questions on this?
No, ma'am, I don't.
Okay. And now, if we look at our parallelogram, you said you didn't understand this last one with the diagonals.
Yes, ma'am.
Okay. Now, what it's said is that my diagonals bisect each other. So initially what I had done was, oh goodness gracious me. Initially what I had done, please, is I had made the markings like this, okay? And then I realized that this is not correct. Why? Because this is basically telling me, and let's call this E, let's call the point in the middle E. What these markings are telling me is it's telling me that DE is equals to AE. Do you see that?
Yes, ma'am.
But actually it's not. Why? Because if I look at just my diagonals by themselves, if I look at just my diagonals by themselves, my diagonals are not equal to each other. So in other words, line AC is not equal to line DB or BD. So because of that, I can't go and have the same markings like this on all of them. I think that's probably where I lost you, when I made the wrong markings and I said that they're not equal. So what I am saying, please erase it up. What I am saying is that my diagonals are not equal to each other. I know they look like they're equal to each other, but remember, we can't assume. And my properties have not told me that my diagonals are equal, meaning they have not told me that line DB is the same as line AC. They have not said that. So I cannot assume, even though it looks like it's the same, I cannot assume that they are. And so what they have told me, though, is that my diagonals bisect each other, meaning line DB cuts line AC exactly in half, meaning AE is equals to EC, and line AC also cuts line DB exactly in half, which means now that EB is equals to ED. Does that make sense?
Yes, ma'am, it does.
Okay. I know it's a lot of words and a lot of info, but I think once you really go over it, it starts to make sense.
Yes, ma'am.
Thank you for the question, Italia. I'm sure a lot of others were lost as well, but just didn't want to say anything. But now that we are back here, if you have questions, guys, please do ask. In the meantime, though, while I do wait for a question, I am going to move on to a rectangle. Now, a rectangle is a shape you guys are familiar with. So I'm assuming most of these properties should be familiar to you. The first thing that they've said is that all four interior angles are equal. Okay. And now this can be further broken down. If all four of my interior angles are equal, that means that all of my angles were supposed to add up to 360. If I divide them by 4, because I now have 4 equal angles, it means that every single one of my angles in a rectangle is going to be a 90-degree angle. And I think that you guys would have known that already. In a rectangle, we have 4 90-degree angles. Also in a rectangle, we have both pairs of opposite sides that are parallel, meaning this is my first pair of opposite sides and they are parallel, and this is my second pair of opposite sides and they are also parallel. So what they've said is that both pairs of my opposite sides are parallel. Looking at the next property, they have said that both pairs of opposite sides are equal. So this is sounding very similar to my parallelogram. Okay. What was different though is I see in my rectangle, I have 90-degree angles in the corners, but in my parallelogram, I don't. And then if we look at our last property here of a rectangle, they said that my diagonals are equal in length. So here, they've told me my diagonals are equal in length. So if I have to draw in my diagonals, and I really just want to do this so I don't have to try so hard. Okay. Okay, line, what are you doing? Sorry, give me a moment to try and fix that. Okay. That is my diagonal number 1. And if we look at diagonal number 2, I really don't know why it's not following my mouse. Okay, it's a little bit slow. Fix that. And over here, okay, that's as good as it's getting. Those are my 2 diagonals. What they've told me is that those diagonals are equal. So if this was a named rectangle A, B, C, D, what they're telling me is that line BD is the same length as line AC, because in a rectangle, my diagonals are equal. But also what they've told me is that my diagonals bisect each other, meaning they get cut in half. And because those diagonals are equal, it means that when they both get cut in half, both of their different halves are actually going to be equal. Couldn't think of a better way to explain that, but let me know how we're feeling about this. Does this make sense? Are we following? Are we like, ma'am, this is a lot. This is too much, ma'am. Brain break, same. I'm with you on that one. I feel like everybody's quiet. I feel like everybody's lost and just not saying anything. I hope that you guys are not lost. No questions. Hopefully, Uma, hopefully. We have 2 more to go through before we get to the brain break. And the brain break is short. I told you guys we had a very full session planned today. So last 2, we're going to power through. We are going to power through. We have rhombi. Rhombi, by the way, is plural. Single version is rhombus. Okay. We have rhombus. Itandile, I know. I've done this a million times and it breaks my skull too. Okay. So they have told us in a rhombus, all 4 sides are equal. Cool. Not a very difficult property to remember. They've now told me that opposite angles are equal, meaning that angle will be equal to that one, and this angle will be equal to this one. Opposite angles are equal. They've also told me opposite sides are parallel. So back to my opposite sides, and the opposite sides are parallel. And again, guys, it's so important to remember which lines are parallel, because if they give you a geometry problem and say this is a rhombus, you have to remember which sides are parallel, because maybe you can use fun angles to solve for your unknown. But in order to use fun angles, you have to know that in a rhombus, your sides, your opposite sides are parallel. So that's that. Looking at the yellow one, it says that diagonals bisect each other, and they bisect each other at 90 degrees. So if I go and draw in my diagonals, ooh, very skew. Let's attempt that one again. If I draw in my diagonals, they firstly bisect each other. So this part will be equal to this part because my line has been cut in half. And this line has also been cut in half. Okay? But not only do they bisect each other, but they bisect each other at 90 degrees, meaning, again, it's the very same thing. If this is 90 degrees, then this will also be 90 degrees, and this will also be 90, and that will also be 90 degrees because of my angles on a straight line. Cool. So that's my yellow property. If we look lastly at our dark blue, they have said that diagonals bisect opposite angles. So in other words, when we talk about the opposite angles, all that we're saying is, remember these are opposite angles, and my diagonal has bisected them. So meaning this will be x and this will be x. They've been cut exactly in half. And because these opposite angles are equal, on this side, this will be x and this will also be x. And this will be y and this will be y because it's been bisected. And because the other side has also been bisected and its angle is equal, it can also be y and also be y. That is a rhombus. Are we all with me? I want to see lots of thumbs ups and not from the same people. I want to see thumbs ups from different people. I've seen only 2, 3 different people so far. Kia makes 4. Are the rest of us lost? Kaylee makes 5. Great. Okay. Okay. I saw some new names, so I'm happy. We're all with me. If you're lost, ask the question. I promise you, there's at least 5 other people who are just as lost and are gonna be so happy that you asked the question so that they didn't have to. And then last, before our brain break, we have a square.
What do you mean when you say diagonals bisect opposite angles?
Okay. So remember what we spoke about when I said that these are opposite angles. So I'm gonna draw my little dots again. Do you agree, Itandila, that these angles that are there by my dots, that those are opposite angles?
Yes, ma'am.
Okay. All that it means is that the diagonals, so this diagonal that's now joining my 2 blue dots, that diagonal bisects those angles. And so you'll see there I have x and x because they've broken it up into 2 equal parts. So all I'm really saying by putting x and x there is I'm saying that they're going to be the same. I'm using the same variable to show you that they are going to be the same. These 2 different parts are going to be equal to each other. And because this angle over here is equal to this angle over here, when these get cut in half, they're also going to be the same as the ones on the other side. Does that make sense?
Yes, ma'am.
You sound a bit hesitant. Are you sure?
Yes, ma'am, I do.
Okay. It's just a lot of info, I think. Once you really get a chance to swallow it down, really sit with it, I feel like you'll feel better.
Yes, ma'am.
Cool. Sorry, I was reading the chat. That was very awkward. Cool. I wasn't talking to you. I wasn't talking to you, Tandile, but thank you for your question. I'm saying cool in the chat. Avril, thumbs up, great. Boy, yes, you are correct. Speak now or forever hold your peace. Kia, yes, do you have a question?
Good evening, ma'am.
Evening.
Ma'am, can I ask something?
Mm-hmm.
How is it a square and how are they different? The square and the rhombus.
Okay. let's look at the difference. All four sides are equal, all four sides are equal. Okay? So far, no differences. Here, they've said that opposite angles are equal, but here, they've told me that all four interior angles are 90 degrees. So in my square, I have 90-degree angles in the corners, okay? But in my rhombus, my angles may not be 90 degrees. For example, this angle over here might be 40 and this might be 40. And then what is that? I'm trying to think of numbers that are going to work. Going to be 360 less 80, which is, just ignore my calculation, which is going to be 280. And then this angle here, because I can see it's an obtuse angle, it looks bigger. This might be 140 degrees and 140 degrees. So do you see that? Yes, all four sides are equal, just like a square. But in a square, my angles are all 90 degrees, whereas in a rhombus, only the opposite angles are equal to each other, and they do not have to be 90 degrees. Does that make sense?
Yes, it does.
Let's look if there's any other differences. They've told me here that my opposite sides are parallel. Opposite sides are also parallel in a square. So that's similarities. So similarities will be in pink, all four sides equal. Opposite sides are parallel, opposite sides are parallel. And my differences, I'll do green. So that's a difference there. Here they've told me my diagonals bisect each other, but they have not told me that my diagonals are equal, okay? So here my diagonals bisect each other at 90 degrees, sure, but here my diagonals are equal in length, okay? But in both of my rhombus and my square, let me highlight it here, the diagonals bisect each other at 90 degrees. Okay? And again, a similarity. Diagonals bisect opposite angles. Diagonals bisect opposite angles. So let's look at what the main difference is. The main difference are these two green points I have here. The main difference is that in a rhombus, my opposite angles are equal, whereas in a square, all four angles are equal and are equal to 90 degrees. And the last difference is that in a rhombus, my diagonals are not equal, but in a square, my diagonals are equal. Make sense?
Yes, ma'am, it does.
Cool. I'm just going to erase all of this markings. Thank you for your question, Kia. Okay. And so on that note, I've kind of gone through now our properties of a square. We have that all four sides are equal, again, just like a rhombus. They've told me that my opposite sides are parallel, also just like a rhombus. But here is where the difference comes in. Here, all of my angles are equal to 90 degrees, so all four angles are equal to each other. My diagonals are equal in length, and they bisect each other, so meaning, oh my gosh, meaning all of my parts are going to be equal over there, and they bisect each other at 90 degrees. Cool. And then my diagonals bisect the opposite angles. And so because I know this is 90 degrees, each one of these angles, when they get cut in half, they're going to get cut at exactly 45 degrees. Okay. Are we all following? Does this make sense? Any questions? Okay, I'm seeing some thumbs ups. The brain break, I'm literally going to take 2 minutes for our brain break, Uma. Now, what I want you to see very quickly is we have sort of a family tree over here with quads. Okay, we have the big family tree of quads. Quads can be split into trapeziums, into kites, and into parallelograms. Parallelograms. Okay. By the way, you should know the shorthand version of that in maths is a palm. So instead of writing parallelogram, you can just write palm. No, yeah, this is not part of the brain break. So now underneath my parallelograms can be split into rectangles and, oh my gosh, and rhombi. And then lastly, we have squares at the bottom of my family tree. Now, what does this mean? It means that all rectangles, all squares, and all rhombi can be a parallelogram, because all shapes at the bottom here have the properties of a parallelogram, that we have opposite sides were equal. We had that opposite sides were parallel. We had that the diagonals bisect each other. They all have those same properties. But a rectangle has a different property in that all my angles are 90 degrees. My squares has a different property in that my diagonals are equal to each other. And my rhombus has a different property in that, what was the different property in my rhombus? In that here, all four sides were equal. Okay, so that is that. That is our family tree of quads. We literally get a 2-minute brain break. Let's go. 3 cycle, no, Uma. Try again. Tricycle, Shady has it. Yes, Liacho. No, whose hand was up first? Hold on. Yes, Liacho, your hand was up first.
Ma'am, I was just about to say tricycle, actually. Like, it was in my mind right there.
Maybe you can try the next one.
Maybe.
We've
but
had
ma'am,
one similar to this.
but ma'am, you can let other people go. Can't always be me.
Okay, Liacho, I mean, you didn't answer the first one, but that was very nice of you. Thank you.
Yeah, you're welcome, ma'am.
Unati, I saw your hand. Do you maybe want to try?
No, ma'am, I'm good.
Okay. Itandile, yes.
Scheme reading.
What was that scheme reading?
Yes, ma'am.
What is scheme reading?
Is when you take out important, like you don't read the whole entire paragraph.
Like
you read
scheme.
important.
I'm
Yes,
thinking
ma'am.
scheme, like SCHEME. That's why I was like, what is scheme reading? No, it's not scheme reading. I thought you guys would know this one. We had one very similar before.
Big reading.
No. Let's see if there's another hand that might know. No. Between reading, Tail is getting somewhere. Mlu, I really would love you to tell me how to say your name. MLU. It's like boggling my mind. I don't know. But anyways, you are correct. It is read between the lines. It is reading or reading between the lines. It's reading between the lines. Another one, we have this funny word. Any ideas? Kia, yes?
Ma'am, 1 million.
Close, but not quite. The chat is helping you. It is 1 in a million.
Are you serious, ma'am? I was about to get that one.
Ma'am,
Sorry, Liapo.
Yo, I had bad luck today. But anyway, it is what it is.
Okay. Let's move on. Oh. Father. Anybody with the answer to this one? Uma was quick with it. It is Robin Hood. It is Robin Hood. Because it's Rob in Hood. It's Rob in the word hood. And then Robin is Robin Hood. Yeah. Okay, last one, guys. This one I feel should be easy. It should be easy. Come on. Yes, Brie.
Ma'am, it's apple pie.
100% it's apple pie. Okay, guys, that was our brain break. Very sad brain break, but it is what it is. Quads, as I say, geometry shows us flames. It really humbles us. It keeps us in check. So, sorry. I heard a hand, Uma. I'm assuming
Ma'am,
you want to answer.
ma'am, we
Yes,
actually have 2 minutes left.
Answer,
It's
answer.
kind of
I
short term.
know. Crazy, right?
Yeah.
Okay, Uma, let's see. Do you want to answer?
Yes. A is
Okay.
equals to 135.
Okay. Firstly, we have to identify the quadrilateral. What do you think the quadrilateral is?
Parallelogram, opposite sides are equal and opposite sides are parallel.
Yes. Okay. Yes. So we are going to say A is equals to 130. Well, no. First, we're going to say A, B, C, D is a parallelogram. Why? Because of opposite sides parallel. That's properties of a parallelogram. Now, again, keep in mind, I know that rectangles also have opposite sides that are parallel. Squares also have opposite sides that are parallel. Rhombi also have opposite sides that are parallel. But remember, we can't say it's a square because I don't know if all four sides are equal. I don't know if my angles are 90 degrees, so I can't say it's a square. So if you don't have enough info to go deeper, you're just going to say it's a parallelogram. And because we only know that my opposite sides are parallel, I'm going to say it's a parallelogram. I cannot go deeper and say that it's a rectangle when I don't know that, that the properties that specifically relate to a rectangle will be present. So that is why we're saying this shape is a parallelogram. And because of that, I can say A is equals to 135 degrees. Why? Because of opposite angles in a palm. Okay, opposite angles in a parallelogram. One of my properties of a parallelogram is that opposite angles are equal to each other. So that is that. Thank you, Uma, for answering that one. I do want to possibly do this last one before I go. Here they've told me that ABCD is a parallelogram. Determine the value of X. Now, what I want you guys to see is there's actually two ways you could do this. Because they've told me it's a parallelogram, I know that it's a quadrilateral. Because I know that it's a quadrilateral, what I could do is I could add up all four angles and say that they should be equal to 360 degrees. And my reason would be sum of angles in a quad. But I see an easier way. Because I know it's a parallelogram, I know that my opposite angles are equal. Oh, and actually, this is not going to help me. Nobody is going to help me. I have x plus 5 degrees should be equal to x plus 5 degrees. And this is my reason will be properties of a parallelogram or opposite angles in a parallelogram. And when I do this, I can go and say, yeah, no. Again, guys, I've used a tool. I see it's not going to work. Look at why it's not going to work. I have x. When I transpose this x over, what's going to happen is it's going to become minus x. And then I have 0 on this side. And I'm going to end up with 0 on this side when I transpose my 5 as well. So that is not going to work. So again, what I've been telling you guys is you pick up a tool, you see it doesn't work, that's okay, let's try again. So we go back to my original method. I am going to have to say 125 plus x plus 5 plus x plus 5 plus 125 should be equal to 360 degrees. And my reason is sum of angles in a quad. I'm not going to solve this equation. You guys can do that. I trust that you know how to solve equations. You would solve this equation to get your answer for x. I will show you guys the...
Now I have another way to do it, ma'am.
What was your way?
You can do co-interior angles that would work.
You are also correct. You are so correct. Uma has said it's a parallelogram, and they've told us that these these sides are parallel. And so because they're parallel, we could have used fun angles. So over here, where there's a U, we could have used co-interior angles.